which has the bias. The input 1 connected to the output neuron using W1 way. The neuron 2 will connect to the output neuron through W2 way. Okay. So that we will be getting an output neuron Y. So we assume initially W1 is equal to W2 is equal to 1. Right? When we consider bias is equal to 0, we are unable to come up with the results. Convergence. Usually we say algorithm convergence. Algorithm convergence means all possible input for algorithm producing the correct results. That meaning is convergence. Okay. So we are unable to come across the convergence. So what we will do? We will now we assume our P is equal to minus P. Okay. What is P? P means bias. I am considering bias is equal to minus. Then W1 W2 is equal to 1. Now we will test the same case. When x1 is equal to 0, x2 equal to 0. First we have to understand this equation. What is y? Y is equal to x1 multiplied with W1 plus x2 multiplied with W2 plus bias. This is how one can express the neuron, output neuron. So now we have to evaluate this one by assuming P is equal to minus degree. Our output y is equal to now x1, W1, x2, W2 minus. Now you try with the possible input. X1 is equal to 0, y1 is equal to 0, then what is your y? Y is equal to minus 3. Right? So this component is 0, this is 0 because x1, x2 are 0. Then the second input, x1 is 0, x is equal to 1. What is your y? x1 is 0, so this is 0, x2 is equal to 1, so we will be getting 1, W2 is 1, 1 minus 3, right, you will get minus 2. Now x1 is equal to 1, x2 is equal to 0. What is y? x1 is 1, so W1 is 1, so you will get 1 minus 3, because x1 is 0, so you will get again minus 2. Then x1 is equal to 1, x is equal to 1. What is your y? 2 minus 3, you will get minus 2. Now if you look at this output, now we see output is what we told actually. This particular component we have to visualize like it is having 2 1, right? Summation plus activation. So we have done only now the summation. This result is only summation. We have to apply activation after, right? Again, what activation I choose? I choose like y is less than 0. The computed result means you value like this. Summation result is less than 0, then y is equal to 0. If summation result is greater than 0, this is equal to y is equal to 1. This is how we have chosen the activation. Okay. So now according to this, what is your output? So this is less than 0, right? Minus 3 is less than 0. After applying activation, you will get output. What is your output? 0. Then this is also less than 0, so output is 0. After applying activation, I mean this is minus 2, this is equal to 0. Right? Then, okay, the 3 test cases will be equal to 0. Then this is also minus 1 is equal to 0. So what is expected? That 1 means we will get y is equal to 1. Then what we have to do now? We have to update the weights. Right? We have to update. Earlier when bias is 0, we are unable to convert. But now we have some idea, right? Now you have a clue now. Which one we need to update so that we will make this is equal to positive. When this become positive? 2 minus 3. Right? Sorry? No. This one is given. This one always is true. You see when you come W1 W2 is equal to 1. So bias we have minus. So now what is it we have to do? We have to make this result greater than this minus. By means of adjusting this W1 W2 it is possible. Provided we should not disturb this result. Right? When you are updating it, then if you are changing input combination, what is the output you are getting? call one FO. Okay. So then the second FO, we are updating the weight, then we have to use updated weight. Now updated weight again you have to go same. Then x1 is 0, x2 is 0. What is your summation? This is FO of 2. So what is the summation result? Y is equal to minus 3. Because the x1 is 0, x2 is 0. Right? When you are doing this one, then you get 3 only, right? And the next case, x1 is 0, then what is that you will get? Summation result. So you get here 2, right? So 2 minus 3 minus 1. Then this becomes 1. Then you get 2 minus 3 minus 1. Then both are 1. You get 4 minus 3 plus 1. Now again you have to apply what? This is summation only, right? Right? Activation here. What is the activation result? Y this is minus 3, so it is less than 0. Output is 0. But this is less than 0. It is less than 0. It output is 0. It is less than 0. Output 0. Then this one greater than 0. So output is 1. Now all our possible input we are getting correct output. Right? You got able to get the AICTE output. Right? So this is the state we call what algorithm converge. So when algorithm is converged, you need not to do the weight update. Is that clear? See, since this particular test case is failed, we updated the weight and we have tried with the updates of things. We have tried with all possible inputs that we are evaluating the corresponding output. Okay, this is the idea. Okay, so even one input combination, you are not getting expected results. What is the procedure we follow? We have to update the figures. Okay, so weight update means learning. Please understand. Weight update means learning. What way it is learning? Based on input data. Whatever we are giving that input with the labeled output. How we are evaluating whether it is giving correct result or not. We have labeled output, right? For this input we should get this output. So supervised learning, simple perceptron learning rule. This is the simple one of neural network net. Okay. With this we can use to design any of the logical function. Okay. So since the problem is linearly separable, the problem what we have taken is linearly separable. That means why it is not linearly separable. So we can make this problem understand. So this is 0, 0, right? Output is 0. So 0, 1, x to y is 0, this is also output. To the right, this is the point. Okay, so then 1, 1, you will get here from there, right? This is the point, 1, 1. So 1, 0, you will get here, right? 0, 1. You see, when my input is 0, 0, output 0, this is actually 1, 0, output 0. This one 0, 1, output 0. What about this one? 1, 1. Right? So now these are two classes. By means of simple linear line, right? I am able to classify. Less than this line will be called one class. Greater than this line will be called second class. So simple linear classifier, we are able to classify this group of data. Is it clear? So we are using simple network. Okay. So now you think of exclusive OR. What is the exclusive OR output? Means so when both the inputs are same, output is 0. When it is different, output is 1. Okay, so now this data, it is not linearly separable. Please understand. Why I am saying it is not linearly separable? So once again you can plot the results to something. So from 0, 0, what is the result? 0. Right? Then 0, 1, x is 0. Possible to classify this by using linear. any line if we are making graph square like this, less than this again it is class right? This is one class, this is another class. Here also greater than this is one class, another class. Any kind of linear equation, just take it is not problem. So this problem is called what? Non-linearly separable problem. Okay. So when your data, your input data linearly separable, then you can apply linear classification. Again, in the neural model, you can require only simple neuron, it is also to be able to identify. We have converged here, right? We are able to get the converged results. That your input is XOR, again it is a non-linearly separable. We cannot do with the help of the simple net. We have to use additional neuron. Okay. So you require in that case the hidden layer. So this is input layer. This is output layer. This one hidden layer. So again the connection is again same. Every neuron you will be having some connection. This neuron also having bias. Okay, this is also being like what? It is an activation. Summation plus activation. So now this is how what? From 1 to 1 some weight. Let us start with this. Maybe 2 or 3. 1, 2. Right, this one. 2, 3. And this output is 2, right? W is 4. This will be W3O. Likewise, now the rhetoric change. You see, that input is non-linearly separable. We have to use some hidden neurons. Again, how many hidden neurons you can use? That is so far no proof. If there is some rule says based on number of output, you will be getting some combination. But the problem, that is why we have said, that it is a black box. Even if you use 2 neuron in data, it will work out. Or 5 neuron if you are using, that also you will get the proper results. So nobody knows what is happening inside, why it is not giving the results properly. Okay. So any model, if you have a non-linear in nature, non-linearly separable, then we have to use hidden layer. Then again the procedure is same. Please understand the procedure is same. What procedure? You have to apply the input. Then how to compute the change of weight? We have some formulas. But a different algorithm follow different strategy. Then we update the weight. Again we find the weight. Likewise we can do. So how they will find out the change of weight means that they will compute the error. What is error? See, output I suppose to get 1, but I am getting 0. Means what is the error? You just subtract expected with the predicted. So then we will get an error value, right? Then if error values are more, then you have to reduce the weight. Right? If errors are less, then you can, the way how we can reduce the weight, that will give you some code based on the error value. So now, idea is we have to back propagate this error, right? We have to back propagate this error, so that with the help of that we update all these weights. Okay, so this is called back propagation of error.